and I can engineer it so that it happens with every recursive call. So every recursive call, this maximum might well be where m is 0, for example. It will be t of n minus 1, right? So in the worst case, this quick select will also have a recurrence which says t of n is t of n minus 1 plus n, just like the worst case for quicksort, even though we are not doing both halves. We're doing only one half. And quicksort, the other half disappears because if in the worst case, sorting.
Okay, so we can say that the complexity is n square, right? The worst case.
Okay. Yeah.
Just like quicksort also has the same complexity. And the complexity,
Can we go to that we can check the best case if he has referred in that same point? No.
Best case is what?
N log n. No, down. Yeah, if you continue that. N log n or.
When our pivot is an extreme value, then either I will have an empty lower part or an empty upper part. So m will be either 0 or n minus 1, and I can engineer it. So
sorry, Uma, the best case is when you have it exactly at the pivot.
So n log n, right? Then.
Why n log n?
No. The best case, what is the time complexity?
So best case is, so let's say you have 10 elements. Okay, you want to find the third maximum.
Yeah.
Or something like, so if the pivot is at that position, okay, so you have on the leftmost part, you have 2 elements. On the right hand side, you have 7 elements, which means the pivot is the third one. I mean, third largest. I mean, third smallest or something.
Okay.
You get the point?
Yeah.
So in one iteration, you will get the answer.
Okay, so order of n then, yeah.
Navika, did you understand?
Yes, I did.
Okay.
So that your m is 0, for example, select worst case for queries, because if in the worst case, sorting the empty half quick. But last time when we had looked at this recurrence tree analysis, but it be in 1/3 and 2/3, right? So if you arrange the values, if your pivot is guaranteed to be in the middle third, so supposing my values are arranged in ascending order, I'm not promising you the pivot is in the middle, but I'm saying that the pivot is going to be somewhere in this segment between 1/3 and 2/3, and it can be 1/3, 2/3, can be any fraction. It could be 1/5 and 2/5. This is also fine for or 4/5. Sorry. So for any fixed, if I can knock off a fixed fraction by choosing a good pivot, right? Then the claim is that quicksort will actually become n log n. So last time we saw for this 1/3, 2/3, right? So supposing the pivot lies between the maximum value by 3, it is that we are guaranteed that the question is whether of give us a fixed fraction of elements that will be pushed as the fixed position. Clever do write into and so on. Now for each block of 5 in the middle one, or we can just rearrange it by any standard sort.
So this is where the medium of medians comes in the picture, right?
Yeah, it's okay. We can move forward with the questions.
We'll move back to the questions.
So Gokul, we saw in the GitHub notes right now that for descending order in the quick select, the time complexity is order of n log n, right?
Yeah. Then
Will
what
it be
about
the same?
order?
Will it be the same for ascending as well?
No. Oh, wait. Repeat. Can you tell me? You are saying order?
Yeah, I'm just talking about the second point only. For the descending order, this is the complexity n log n.
No. See, if it is ascending order or descending order, the complexity is 1. I mean n. So not even n, it is 1. You can directly select that, right? Navika.
Yeah.
So if it is already sorted.
Yeah.
So if I want to find third element, you got the point? So here they are saying it's a jumbled sequence. So they are saying, so since this it is asking you to select the third, its smallest value, they are sorting in the descending order. And look at the position K.
Okay. So what does this n log n implies then?
For the sorting.
Okay.
Making the the jumbled sequence as a sorted one.
Okay.
Uma, was it correct?
I'm not sure, Gokul. I'm not getting. Yeah.
Okay, we'll go back. So I think this is all about quick select and max heap, something only that much, right? So we'll come back to this question here. We'll finish it off.
N square. Just now we saw, right? First
Yeah,
case.
correct.
Yes.
So
Max
we have
heap.
something called this max heap.
Um,
Okay. Okay, what is a max heap? You guys know about this,
Yeah, yeah,
yes.
yeah,
right? So in max heap, we have the maximum element always at the top,
yeah.
Right.
right? In between can be any order. Okay, it doesn't matter. But the maximum element will be always be at the top.
Mm.
Okay. In such a scenario, if you want to find out the what
Kth worst. Sorry.
the kth
Kth
smallest element,
smallest. Yeah. Then you have
correct?
to go
So you
down.
knock
Right?
off that many number of times.
Yeah.
Deleting and the restructuring of this will take that much time again.
N log K, right? Maybe.
N log k. So ns, you are searching for it, right? And the log k times you will be able to get that.
Yeah.
Navika,
Yeah, Gokul.
how much
Understood.
did you understand this?
I did understand this. I mean, for the quick select one option, I understood. We just saw in the video,
Yeah.
and I'm clear about max heap.
Okay.
I don't have issues in heap. Yeah.
Yeah. Subramanyam, anything you want to ask?
It's okay, but if it is in the ascending order you are talking, no?
No.
If the heap is in the ascending order when we are organizing it, no?
No. What is a max heap? Max heap means always it's not in the order. Only the maximum element will be at the top.
Only the maximum element in the top and the other elements are in the random, is it?
Yeah, in the random order, correct.
What
No,
we are
not
telling
in
is
a
very
random order. The max heap is only
Every
connect this. Your parent should be greater than the children. That's it.
yeah.
Correct, Uma. So random order in the sense it's not in a sorted order,
Yeah,
basically.
yeah. That is sure. True, true.
but that doesn't really matter because we are interested only in the maximum, is it?
Yeah,
Correct.
that is why it is taking n, because the worst case you have to go down because we are searching a smallest element in a max heap. It could be any level. It could be in the level, so it could be down, right? Smallest element will come at the as much as down.
Correct.
Min heap also same answer will hold.
No, because min heap it will have smallest elements. It will be much faster, much above, right? The first element will be the smallest. Second element could be under the root, right? Second smallest will be one of the child. It is a must, right?
It's always the child, you know.
Yeah, the top smallest will be the upper point. Next, second smallest will be either left or right, things like that, right? So it won't be, and you don't have to go down a lot, kind of.
Right. This is an example of a max heap, right?
Okay.
Okay. So if you want to
Right.
find out, so what is the worst case? So worst case is trying to find out the the fifth smallest.
No, you are actually written. Have you written min heap or max heap?
This is
Max
max
heap.
heap.
Yeah, max heap. If you are finding min, then you are going down, right?
Correct. Exactly.
Yeah.
Okay. If I'm telling that, what will be the fifth smallest element in this heap? So how will you find out?
You travel to the bottom, right?
Left and right we got to travel and find it out. No?
Yeah, log n. So and the height is log k. So I
My
think that's why
question
it
is,
is n log k.
yeah, even if we have 5, 4, 1, 2, 3. This is also max heap, right?
Yeah.
5, 4, 1, 2, 3. This is
No,
also
this
max
could
heap.
not be maximum
Sorry, Uma?
because 3 is greater than 1.
No, I'm saying that 3 is here. Why should 3 come there?
This is max heap, right?
Yes.
1 cannot be there, right?
Why not?
Oh, only the parent? Okay. Okay, yeah.
Right. So how do I find out the fifth minimum value? Tell me. Fifth smallest element in the array.
This is the first one.
First, you will knock this off.
Yeah.
I mean, now 3 will go up and 5 will come here, and you're removing the maximum element. Okay, you just need to remove the maximum element 5 times. Okay, 5 times remove max. So when you remove the max, again the restructuring happens, right? So that is log
Only
k
the
time.
left arm will get restructured, right? Will not change,
Repeat.
Only the left arm gets
Yeah,
restructured.
in the scenario, only the left arm will change wherever the element is present. You're right.
Okay.
And they are given log k because you just need to knock it off, k number of times.
Okay.
See, look at this. Using max heap of size k. So n is the total number of elements. So if the size of the max heap, size of the heap is k, then you will take log k times to restructure it. Correct?
Yeah.
Right.
So n into log k. So that's how this option is correct. Does this work now?
Yeah, got it. Yeah.
Okay.
If it would have been okay, the largest element, we will have using min heap that order of n log k.
You're
It
right.
will be
Okay.
reversed. Yeah. Okay.
Yes. Fine. So Navika, we'll move ahead.
Yes.
Here. This is fine. This is fine. Okay. The fourth question. Which of the following lists all pairs of inversion for this? This is an easy one, right? 1, 2, 3, 4, 5. How do you find the inversions? Navika, do you know?
Yeah. Now you will be writing in the second row. You will be writing 1, 5, 4, 2, 3.
Right? Yes.
Yeah. Then
Go
we'll
ahead.
be just simply we'll be just you know joining 1 to 1, 2 to 2, and then we'll be finding the pairs. So I think it is 5,
This is
4.
pretty simple, right?
Yeah. So it is 5, 4, 1 for sure, and then
I'm putting this like this, okay? So in order to see how many number of intersections you have, okay? So what are all the intersections that you have?
so we have 5, 4, 5, 2.
Okay. So these points I need to circle, right?
Right. 4, comma 2,
Right.
comma 3, 4. I think the second one is right. Second option.
So looking at this, we can say that 5, 4, right?
Right.
Then the 5, 3 also is there.
Hmm.
Then 5, 2 is also there. Then
4, 2,
4, 2.
and
Then
4, 3.
Subramanian, are you okay with this? Kuma?
Yeah.
Subramanian, any doubt on this? Okay.
One second, Gokul. Instead
Yeah.
of drawing this, just now we remember you saw the code, no, above one. So with that
Correct.
code, if you think if the first element is greater than how many numbers, we can just go ahead with that in the A list instead of drawing this because of the numbers.
Okay.
See, 5 is greater than 4, so it is one inversion. 5 is greater than 2, second inversion. 5 is greater than 3, third, 3 inversions.
Simply you're saying 5, 4, 5,
Yeah,
2,
because
5,
just now we saw the code. The code says first element, whether we check the neighbor element, right?
Oh, yeah.
So that will be much easier than if they give like this. I don't know.
Yeah. Okay. I got the point.
Now, how did you guys reach over there?
No, we just saw the code. Actually, you get for the first element, check with the other elements. If it is a greater, how many numbers it is greater than in the list? That counts as an inversion. The count there.
From look at this. One is smaller than all the rest of the elements, correct?
Right.
So there is no inversion. So come to 5. So how many elements are 5 greater than 4? So 5 is greater than 4, 5 is greater than 2, 5 is greater than 3.
1.
Got the point?
Right.
Okay. So now move to the next element. So
What
4.
happened to 5, 1?
5 is greater than 1 now, so you don't need to worry about that. So you have moved past it.
Okay.
Just need to check the remaining right hand only. You need to look at the forward end, not the backward end.
Okay.
Right? So 4 is greater than 2 and 3. So you have 4, 2, 4, 3. And see if you take 2, 2 is not greater than 3. Right? And if you take 3, 3 is not greater than the remaining. That's also that's how you get the answer. Correct?
Right. Okay.
So one last question.
In that line crossings, no, what is the theory behind choosing that one? What is the theory behind choosing those?
This is just a shortcut to get the pairs.
No, I understand. Shortcut to pick up the answer. But what is really happening in these lines and the
I
crossings?
would I would suggest you to watch it later because we have discussed this already. I'll send you a link what
Okay.
inversion actually means. All right.
Yeah, what the theory behind it? I'm just curious to know.
Can I
Yeah.
say, Gokul?
Yeah, Uma, if you can make it
Actually,
now.
Subramaniam, it is like a rating given by two people. If you can compare, one person has given this rating, you want to compare how much dissimilar with the first person. So
Okay.
for a second movie, the first person's second rating, but he has given 5, right? So how much dissimilar you are checking? So you're putting a line 5 to 5. So he has given 5 there, and you're cross checking that line. How many has crossed? So that counts as an inversion. So he
How
has
many
given,
mismatches you
yeah,
guys?
mismatch. It's kind of like that. So if it is crossing something, then it is a mismatch. See, the first line doesn't cross anything. So both are
Okay.
correct. There is no inversion.
All right.
Second
So
person has given,
every crossing points are the mismatch points.
yeah. Then if you,
So 5 and 4. Okay.
yeah. So it's not matching, right? How many it is not matching? How far the ratings are?
I'm with you. Right. Okay.
That's all.
Thank you.
Okay. So this question, what is this question about? Which of the following options are correct with respect to the recurrence relation of fast select? Okay. To find kth smallest number. Wait, median. So median of the block medians of dividing the input into 7 blocks. Okay, using median of medians. So I believe Navika, do you know what is the median of median?
I don't understand this question.
No, not the
Well,
question. Do you know this concept? I'm asking you. Do you know what is median of median?
just a second. Just recall. I think I'd gone through this, but I'm not able to.
Okay. So let's say that you have. How do I tell this? Let's read this. So you have like 50 numbers in this place. Okay, how much?
Local you draw 15. I will tell you quickly.
What do you want me to do?
You can draw, if you take a list of 15,
Okay.
instead of going through the n elements, you can take 5 elements. So you will not have an n run, right? You will not have an order of n. You don't have to go through the full list. It is just only blocks of 5. So take
Okay.
the middle of that, median of the 5. Then second block, median of that 5. Third block. In this case, you are avoiding the choosing median for n complexity for choosing median. Got it, Navika? Then these 3, you're getting a median. So approximately you'll get a median in the center without this n complexity, order n complexity.
Okay.
That's the median of median.
But the numbers are going to be arranged in random, right?
Yeah, no, you are going to sort it first, but you're sorting only 5, right? You're not going to
Oh,
sort n elements.
so we're
It
gonna
is
sort the
always 5.
5.
Yeah,
First
5.
5.
your loop is going to run only for 5. This is a constant, right? It is not order of n complexity. So 5, 5, 5, it is always 5. Even how many 100 numbers you take, you're going to run only 5. Then collect all those medians, then again split 5. If it is 100, split that 5. So your loop will run only for the constant time of 5.
Got the
You'll
point.
never, yeah. So then finally you're collecting the median, then finally you get to 1 median, which we believe it is approximately in the middle, definitely not in the first place or the last place. So that when the pivot is middle, your time complexity is drastically reduced for both. So I think for fast select.
So is it like is it necessary to always divide in a block of 5? For instance, if we have 9
No,
elements,
7, 9 elements you can go for 3. It depends on the whatever
it
the
needs to
sum.
be okay. It needs to be equal. It cannot be
A
5
block,
and 4.
a block. That's all.
All right.
Whichever, yeah.
Because that's what I'm saying. So the what do you say? The length of the block should be same. It cannot be 5 and 4 in the case of 9. It needs to be 3, 3, 3. Right?
Yeah. It depends. Once pick the block, that loop is 5, then it will run for the 5 only.
Okay, understood.
All right. So Subramanyam, all right with that?
Yeah.
Okay. The median of medians lies between. That's okay. So I think we just need to see for the complexity.
Why do we divide that by 10 when it is the row is already having 16 elements in that? Oh no, in the bottom picture it is 10, but in the top picture it is not 10. But the
What do
note
you
is
mean?
corresponding to where? Note corresponds to top picture or bottom picture?
I'm not understanding. What are we talking?
The third bullet, the median of block medians lies between 3 length 10,
3 into length of L by 10.
yeah, and
Okay, it is saying
7 into length of 10.
correct. So they are saying that it is in. So you remember, sir, telling us, the first one third, second one third,
Oh yeah.
third one third. So they are saying that if you do such a scenario, if you do something like this, so we
Oh,
can guarantee that the total median lies in the middle part.
okay. Can you please scroll up? Okay, in this picture, we can't read that bullet, is it? There's no one
Which
third divisions is not there in this one.
No, see, they are
No.
saying that. See, look at this yellow points are the all the medians that you're going to
Correct.
get.
Yes, that's the median of
Five,
median.
five. When you're splitting the list into 5. Okay, yellow block is the median. Okay,
Yes. Yes.
so if you find the median for that median,
Uh-huh.
similarly, same, you can split it into 5 and find the median for that. When you
Yeah.
find the median of the medians,
Mhm.
they are telling that this picture is for a different representation. They are saying that this picture says that three. I mean, the this left you're not going to have the median, and the bottom also you won't have the median. So median only lies in the middle region.
Middle region.
So that's all you need to understand on this.
Okay.
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 So just like how we did the quick select, now we are getting the we are finding the what fixing the pivot by using the median of medians.
Right.
So and one second, guys.
Uma, like for instance, we have 17 elements. Then how are we going to do the division?
You can have anything 5 5. It depends on your whatever the given. You don't have to be exactly that, right? Just you have to reduce the time and complexity. If it is whichever it's as minimum as possible, it is best so that you get the good median, right?
Okay.
For 17, you can say take 3 also, right?
So
The
what's
last
the
list will have only 2 elements. You will not get a median. Kind of like if you go through the
yes?
code, you'll understand much better.
Okay.
What happens to the list which is less number? That's your point, right?
Yeah.
Yeah,
That's
that
what
I
I'm
think
getting.
it is a little more depth. I don't know. maybe you
Okay.
can go through the code. I think it won't return something. You'll get only the medians. If it is only two element, I think you will get one from that list.
Okay.
Finally, the point is you are taking all the median and then just finding the median of that median. That's all.
I think the question
From
is
the list.
valid here because when 17, so you're taking the 5 blocks, 3 or 5 blocks, and the last block is just 2 numbers. No?
Yeah,
So
from that you will. I
one of
think.
it will be median with it.
Yeah. So if you see the code, that will be known. I'm not very sure what happens.
And
And
what's the time?
we don't necessarily need to get the exact median, right? We just need to be approximately in the range of the median.
Yeah.
Oh, yeah.
Okay.
Because
That's
again,
the
you are
given
going to
option.
sort it. Again, you are going to sort the median of medians. So it's not. Anyway, the result is still to be found. So your work, that's a work in progress set. Only what we have. Median of median is just a step before the final step, is it?
Yeah, that's correct.
And what is the time complexity for this? For the
That is
median
what
of
I'm trying. That is
Okay.
what I mean. It's not there in the GitHub, so let's confirm that. Okay, I think we are reducing the worst case complexity with this. So behind this, yeah, median of medians. So we are having the quick select. Look at this. So just for the finding the median, it is big O of n. Okay, and recurrence for the fast select. Max of what is this? Exactly. See, can also use MOM to make quick sort. No, what is this? It is n log n, I believe. I'll just share the video where Sir explains that. And so on. So we can find the median of each block. Now we'll assume or less, and then I just them in 5 elements, then the median 4. So after it out into m, we just each of these blocks at this, right? How many brown elements are there? We had, I think, 3, the smaller part of the thing. So at least 3 by 10 of the elements are smaller than this median, and at least 3 by 10 are larger than the median, right? So that's going to say that the median lies between these, going to be between 310. So I'm going to, this gives us a quick, right? Insert median of medians algorithm on this slice. In the first, and we will just move L so that the rest of it can run as before, right? So I move to the left hand side and as before, except that instead of calling quick select, of course, I'm calling fast select. So the only thing I have done is I have changed the way I compute the pivot. Instead of taking the leftmost element, I'm using this median of medians and then doing it, right? So first of all, how much time does it take to run median of medians? Well, that is easy, right? Median of medians is basically taking the entire thing, doing a linear scan. So in order n time, it's reducing the problem to 1/5. And then it's again reducing the problem to 1/5, right? So this is one of our contracting series. And so this whole thing is going to be dominated by the time it takes at the root, as we saw. So it's going to be order n. So the median of median finding this is actually order n time. So finding the pivot is order n time, and finding the partition is also order n time because I do it in one scan. So overall, as far as this fast select is concerned, right, this part of it remains order n. The processing time at each recursive call without the recursive call being counted is order n. It's order n to find the median of block medians and another order n to do the partitioning with respect to that median, right? And now what do we know? We know that, like our earlier example of quicksort with 2 by 3 and 1 by 3, here we know it is 3 by 10 and 7 by 10. Right? We know that at least that many elements have been eliminated in this, or pushed into one of the two partitions. Right? And since we have this, it is similar to our earlier thing. that we will just keep contracting, right? The maximum of this is strictly smaller. So basically, this recurrence of fast select is going to be dominated by what happens at the root, and I'm going to get that fast select also runs in linear time, right? So this is it should be big O of n, right? So Tn is also big O of n. Right? So we have moved from an n squared algorithm to a big O of n algorithm by using this very clever median of medians argument.
So it says it is ON.
Yeah, I think so.
In order to 7/10 of the positions in the array, right? So we can of course use the same trick in quicksort, right? So in quicksort also we can, instead of taking the extreme element or some fixed element as a pivot, we could call median of medians. In order n time we'll get a good pivot. We will reduce quicksort to taking quicksorting 3 by 10 and 7 by 10, and it will become n log n. Now of course there is a cost involved with this, so there are some constants and all that. So when I say that this is going to be order n, it's going to take some extra cost compared to just doing a partitioning, and we can basically see that in quicksort on an average it will be n log n even without doing this work. So we typically do not use this because this overhead actually makes quicksort slower in the long run, because in the cases where it would run in n log n anyway, by adding this overhead of medians, we are actually doing extra work. But it's useful to know that quicksort can actually be made to run in n log n time in the worst case by applying this median of medians as our pivot strategy. Right? So to summarize, median of block medians will help us to find a good pivot in linear time. And now,
Sorry, guys,
if we
what is the
use
takeaway from
this
that?
as our
Yeah,
strategy
so
to
for
choose the
quick
pivot
select
for our
and fast
partitioning,
select, right? The
then the
worst
quick
case can
select
become
actually
order.
becomes a linear time
Yeah,
algorithm,
am I correct?
and quick sort becomes an
If
n
you
log n
use median of
algorithm in the
median.
worst case with this extra step.
Why is this going up?
This also means that we can
Can't
find
I
the
do anything for
actual
this?
median in linear time, because in particular this
Uma,
finds the kernel
No, it
list.
happened. The
any
portal
So
idea?
in
is like
particular
You
that.
we
have
want
to
to find
open
the
it
kth
again. It
largest
usually
value
happens.
in a
The
sequence of
refresh
length
it.
n.
Yeah, the portal is like that.
So of
It's
course one
nothing to
way to
do.
do this is to
It
sort the
happens, I think, all
list
the time.
in descending order,
Yeah.
and then the largest value is the first one, the second largest value.
Uma,
You got
what
to
did
put
you
in the
say?
full screen, then it will not go.
Huh, that's okay, but yeah, I think I need to redo a refresh in game. Yeah, go ahead, Navika.
No, I was just asking Uma, what did she repeat when you asked
No,
regarding
so
the
with
table?
median of median, both quick select and fast select become order of n, right? Then
No, no, no. Quick
if you
select
use
becomes,
median of median, that is quick sort.
yeah.
Quick sort becomes n log n
Yeah,
when we use
for the
median
first
of
case,
median.
if you use median of, but quick select and fast select, right? Order of n only.
Uma, what is quick select and fast select? The quick select is without using the MOM.
Yeah.
Okay, no, I'm telling if you use, because without using MOM, the order of n square, right? Worst case.
For
That
the
we
quick
just
select,
saw.
right?
Yeah. Worst case is order of n square we just saw, right? For quick select.
Okay.
But if you use MOM, then it becomes order of n, right?
No. See, if you are using MOM inside of the quick select, it see, MOM plus quick select equal to
Fast
fast
select.
select.
Yeah.
Oh, okay.
And for that, the time complexity for fast select, it's order of
Order of
n, right?
n. Okay. So that's what I said
Correct.
for saying it fast select. Okay, yeah.
Yeah.
Got the point?
Yeah.
So that's why I wasn't able to respond when you asked me. Okay. Fine. So now they are saying that now what is this recurrence relation? How do we tell this?
How your this is, I think it is T of n by 7 plus order of n. I think so. Greater than, I don't know.
Yeah, this is something which I think like we have seen, but
That's the one third concept when we are applying that one. No?
hmm,
What is this greater than less
correct.
than? We are not understanding it.
That's what I'm trying to see. So that seems okay, right? So I think they are asking about where the pivot is chosen, right, Uma? So they are saying where will the pivot lie? So it will, I mean, what, n by 7, and 6n by 7. So it's going to lie in between this. Let's read the question again. Which of the following options are correct with respect to the recurrence relation of fast select algorithm to find the kth smallest number in an array of numbers of n numbers, okay, where the pivot is chosen as the median of the block median, dividing the input blocks into blocks of 7, okay. So what is this T of n? T of n is the time taken to find the median, right, Uma?
Yeah.
I believe that's that. Okay, so time taken to find the, not just the median, I think it's the whole thing, I believe. Kth
For
smallest
fast
thing.
select, the complete fast select.
Complete fast select. Okay, so that we know that it is gonna be less than, less than or equal to 6n by 7, right? You don't need to do the other part. That's something which we saw.
Gokul, is the time taken to find the kth smallest number, is it?
That's
Not
what,
the
yeah.
time.
Time
It
taken
will
to
be
find the kth smallest number.
elements
It's not
will
the
be
time taken for the median, it's the kth smallest number.
Correct. So this is ON is the time taken to find the median.
Right.
And also, to combine it. Go ahead, Uma. You want to say something?
I'm telling it is less than n by 7. He told something. No, if the k depends on k. It could be either in this left of the 10 by 7, something like that. I'm not sure what.
No. He told that it will be greater than that and then less than the 7 by 1 if you're doing that. Okay.
So you mean
Okay,
to say
wait.
that one it is in between the last one third and the first one third. That's what it is, no?
Correct. So we don't have it there.
Anyway, and this new list has the size 150. Take the left, which is not sort it. Take the middle element left. Exactly. So quicksort had a list and
This
it
is
had a
for
list
quick select.
of this,
Look at this.
right?
Is
So
that
this the number of things in the
This is for
right
the median,
of this.
Gokul.
Now
The median
correct?
lies
So
here, but
now
this is
grouping into
recurrence
5.
relation. I don't
Now
know
take
what
this
is that.
this 3. Here we know it is 3 by 10 and 7 by 10.
Max of
Right? We know that at least
3m.
max of T3m by 10 and T7m by 10 plus 1. So what do I tell here?
Greater than this one.
Go forward and see have something. No, right? We don't have anything like that. Okay. So what do you want to say, Uma? Go ahead.
No, nothing. I don't know. Maybe I can ask him this course, the meaning.
No. So how I feel is that so they are given it as you are dividing it into 7 blocks. Correct?
Yeah.
So let's go one option at a time. Okay. So let's go with the wrong option. Okay. So do you think it will be less than n by 7 by any chance?
No.
Uma?
No.
So what is n by 7? N by 7 is nothing but something like 1 by 7.
Yeah.
Are we locating the median or locating the
Uh, Kind of. We can say kind of.
No. This is for the whole. We are finding the kth smallest. That is the time complexity for finding the smallest. Now there is no point of MOM. That is inside the algorithm to find the pivot. Now we are going for the kth smallest. So now we have to write the relation for that. This is
Yeah.
nothing to do with me MOM, right? This T of n by 7, we are converting each block. So like you said, it cannot be T of n by less than T of n by 7.
why? If it is the smallest, it could be.
No, no. It's not the case because we are trying to find the median of median here, right?
Oh, you're going for median of median first.
There
Okay.
you told me, where the pivot is chosen as a median of median of the blocks of medians.
No, but Uma was just interfering and telling about finding the smallest, no? So that clarity is needed now.
Navika, you want to say something for this?
No, to be honest, I understood why I understood why
Huh.
like tn less than equal to 6 n by 7 is the right answer and greater than equals to is the right answer, but I didn't understand why not the second option is right.
Second option. Okay, see, consider that you have a line, okay, which is of length 7.
Yeah.
Okay, so this thing says that the recurrence relation is it is going to be less than n by 7. So n is 7 here. So you know what? 1 by 7.
Yeah.
No. Okay, 1 n by 7. So they're kind of saying that it can be in this part. I mean, can it be in less than this part? No, which is not the case, right? I mean, that's what we have seen. We are trying to take it in the middle.
Okay.
If you are trying to locate the middle, then the equation is correct.
Correct.
It lies between 6 by 7 and 1 by 7.
Even let me give you an example. So let's say that we have a 1 lakh number. Okay, 1 lakh random numbers.
Okay.
I think some comma is mistaken. Fine. 1 lakh random numbers. So I'm asking you guys to find out, hundredth, the number which is 100th smallest number. Okay. So how it will happen? It's gonna. I'm gonna take some random numbers. So, but according to this, if you are splitting by 7, I mean, let's go with the how so I used to teach. Okay, let's divide it by 5 and 3/10 and 7/10. So 1/3 of this part, this is 1/3. So which means
30,000.
correct.
30,000.
Yeah. So let's say the pivot is going to lie in this part, correct?
Right.
Worst case, the pivot is going to be at the end of this line, which is going to be 66,666, something like that.
Right.
Right. So the best case is that the pivot could lie over here, which is 33,333. Okay. Now you got the pivot. So the value that you wanted to find, if it is less than the pivot, then you leave the remaining part and take the left of it. Correct. And so you just take the 333 what 3,333 if it is over here. If it is over there, you just take 6,666.
Right.
Now this thing is gonna get divided by 3. So that is where the advantage comes in.
11,000 now. So we will be working out within 11,000.
If we are divided this by 11, so around 11,000. If you divide this also by 11, so I mean, by 3, it keeps on decreasing. That's what I'm saying. So probably in maximum 10 steps you'll be able to reach it.
But when we are talking about the time complexity, how do we do that one? Because we are going cascading it off 1/3, 1/3, 1/3. We are keep doing it, no? So how do we really count the time complexity? It is not definitely n by 3k, something like that. But we keep repeating it, no?
It's okay, fine. If I don't want to spend more time for this, so let's move forward. All right, let's move forward, and we can check this in discourse also. Uma, okay, that's fine.
Yeah.
Yeah.
And at the end, I want to tell. Yesterday we didn't that fun program. You remember that actually
Correct.
actually we misread the question. It was not j is equal to not 1. J is equal to j plus I.
Which question?
Yesterday, which week? Week 10 or week 11?
Was it yesterday?
Yeah. Myself and Pooja was there. No?
No, that was in the previous term question paper.
Oh, okay.
Let's ignore that.
That
Now
was
we
j plus I. It was not 1 Gokul. I just want to tell you that's all.
okay. So was there a printing mistake in the paper?
No, I
Or
think
did
we
you?
whatever he no. I saw in Pooja's paper it was I only. We maybe misread as 1. We all
Okay.
three I think missed it. Because
Okay, fine.
no, I'm talking about the question paper only.
Yeah, I understand that. Now let's finish this off.
Yeah. Okay. Yeah. No, I'm just informing you. That's all. We got the answer.
Yeah, that's okay. I'll look into that now after some time. Now let's come back here. Now we can take this question.
Yeah, which of the following input arrays will have the maximum and minimum inversion pairs respectively? Okay, so the maximum would be in the descending one, and
Correct.
the minimum would be in the ascending. So 2 and
So
1, the
it's 2 and
second
1.
option.
Okay,
Yeah,
go ahead.
this is something which I wanted to understand. Divide the problem into 6 sub-problems, each
Mhm.
of size n by 6.
Yeah,
Number of steps S required to combine these 6 solutions is 2n plus 12. We
correct.
apply this strategy recursively till the subproblems cannot further be divided into subproblems.
Sure. Okay. How do we solve this?
Let's learn this one.
Someone can take this. Uma, you want to take this? Or Subramaniam, you want to try this if you know?
I'm just trying to see whether
I'm just reading.
Mhm. Okay. So now we come.
Yeah.
So solve the problem of input. Let's say like we want to sort a list. Okay. Navika, following?
Yeah.
So,
Follow.
we want to sort a list. Okay. So divide the problem into 6 sub problems, each of size n by 6. So they are saying that n by 6, 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 and n by 6. Got the point?
Right.
Yeah.
So number of steps S required to combine these 6 solutions is 2n plus
1
2.
plus 12.
Sorry, 2n plus 12. So if you want to combine these two, it's 2n plus 12, right? So how? Okay, now what is this? We'll apply this strategy. Cannot be run further. Okay, what will be the upper bound for the above algorithm? So they are
n
saying
log
it.
n.
Go ahead, Uma.
Is it n log n? I think so.
Yeah, it's n log n, correct. Okay, but how do we come up this with this?
Okay, from the tree, no, Gokul, you have drawn a tree, no, n by 6.
Yes,
So what will be the combining time? You to the right hand side, you write is at 2n plus 12.
correct.
Order of
Okay, here in your tree, you just
So in
write.
my key
Yeah,
here,
so combining this, you'll have the time is 2n plus 12. Okay,
okay,
That's given in the problem.
yeah, given the problem. Then this each n by 6, it is going to be 6, right? 6 are problems of n by 6 and with things like that, right?
correct.
Again 6. So that means how many you have? 6 you have. So this 2n plus 12 into 6, can we do that? The operation
2n plus 12.
into 6, right? Some
Yeah, that's
constant.
correct.
Yeah.
Yes,
So
yes.
this way you're going to go to log n to the base 6, right? The height will
Exactly,
be
that's the
log n.
point.
Yeah, the
Yes.
height will be log n to the base 6. That means it is the same thing, n log n.
Yeah, that's the exact point.
Yeah. So
Navika?
n into height.
Hmm.
Yeah.
So Navika, the important point you need to see here is it is log base 6
Right.
What is
and
that
not.
S is doing here?
They are saying that S is the steps to combine. They are just giving some variable name.
It doesn't really drive out the
But
height. S
no,
does
no, no.
not drive the height.
No, we are not using it anywhere, right? At least at this point, at this moment.
No,
The
because it
question,
is S number of steps. So does it not really amount to the height is S?
no. There's
No.
time taken nearness, talking about the time complexity, right?
Hmm.
So that's same thing. 2n plus 2 is the time taken to combine. That's what it is given. Don't confuse much.
You don't need to. I mean, you don't need to confuse about that.
Yeah. Time it number of steps is, I think it is similar to
So
time.
you're only using the 2n plus 12.
Yeah, that is the it is given, right? Yeah.
Yeah.
So to combine the sub problems, that is the time taken. We can say it as a steps also. I think both are same. So
Hmm.
you can confirm with this course. I'm not very sure, but this is the meaning. It is 2n plus 1. That is the time taken. So until you get 1, we are doing that the log that in height
Correct.
2n into that height. So it will be like
Hmm.
constant into log n. Sorry,
Correct.
n log n. Yeah.
So Navika,
Yeah,
how good is your
yeah.
understanding for this?
I understood this that since we are doing it recursively, so we are going that's like that takes log n, right? And
Yeah.
since it's given 2n plus 12, so that removing the constants and all the that's like order of n. I understood it that way, so that makes it n log n.
Okay.
I just pick it on process of elimination. That's all right. Cannot
What
be
if
That-
yeah, sorry.
Yeah, it cannot do n square or n power 6. Also, it cannot do n.
correct.
So the left out is only log n.
In login.
But Uma's explanation is really, I got to read a little more to understand that one.
Okay. See, let's say that if you're given, list of 32 elements. Okay. If we do a quick sort, I mean, if we do a, binary search or something, whatever,
16,
uh,
16.
16, 16, correct? Then
Yeah,
what will happen?
8, 8.
So 8, 8. So it will take
But,
some number of, it will come like at least, in next 3 steps, it will come to 1, correct?
mm, mm,
So at the end, it will be like 2, 2, 2, 2, which we will split into like this, correct?
yeah.
Okay. So this is what you call for a log base 2
Mm-hmm.
because you are splitting into 2.
Mm,
Now, if I have 66 elements,
mm-hmm.
okay, if I split 6 equal parts, which
Mm,
means 11, 11, 11, 11, 11, 11.
yes.
Okay. Now this 11 also I'm splitting into 6 equal parts, approximately 2, 2, 2, 2, 2, 2, 2, 2,
Mm-hmm.
right?
That's end.
Approximately will come like that. So in approximately around 2 to 3 steps, even if it is 66, you are able to go to the end of the regression in very less number of times.
Right.
So that's where the log base 6 comes in.
Oh, because you are dividing into 6, so you're telling log base 6. Yeah?
Correct. Yes. So if you divide into 10, it's called log base 10.
Got it.
Hmm. All right.
Gokul, what if just a second, please? If you just come
Hmm.
back to that, what if like in the problem it's given, we divide it into, let's suppose, hypothetically 8 subproblems.
Yes.
Even then the answer would be same, right?
Still same. N log 8 n. So you will take the constants out. So it will be n log n.
Yeah. So what I mean to say that it doesn't matter whatever the size of the block is, like the subproblem
Yeah.
is, right?
Even if you have
The answer
1,000,
still
it's still n
remains
log n.
the same. All right.
Right.
But in the exams, the recurrence is not that easy. It is so tough.
Yeah,
Always
yeah.
the recurrence never we can solve actually each time. But yesterday also Atul told that, which you remember, Gokul, we got that slides, no, whether it is increasing, decreasing. So if
Yes,
you
yes.
know
That's what
that very correctly, I think we can solve it. So we have to. I have to revise it again. Yesterday he told it, he explained
hmm.
it, but we want to apply and check. And the crucial part is we want to know whether it is decreasing or increasing. If we know that, I think we can substitute in formula. That
That's
is
correct. Yeah.
tough. Yesterday he told, I'm not very sure. See, the splitting, no, if it is kind of more than the base, he's telling it is decreasing, something like that. So you can use the formula law. You remember
So
yesterday in one of the problem we tried, Gokul, it is not coming. You remember?
that's and said that due to the joining of it was in n square, so that's why it took the complexity of n
Yeah,
square.
but still, yeah, I have a doubt on that. This formula didn't apply there. No, it was very different. So it is so confusing, even though we know it. Yeah.
Mhm. So okay, wait, Uma, let me clear this for everyone here. Okay, this is what is important. I'm not going to take the next one. Okay. So, guys, do you remember binary search?
Okay, wait. Same as log n. All terms in the series are equal. Means it is log n. How do I tell this here? Okay. See, we have the merge sort, guys. Hello.
Yeah.
Yeah.
Okay. So in the merge sort, this is what the recurrence relation is, right? You're splitting into two, and two. I mean, n by two, right? Each left part is going to be n by two, right part is going to be n by two. So totally, you are splitting into two parts, correct? And for merging, you're going to take n times. So what this series is equal means is that when you sum up at a single level, okay, so n by 2 plus n by 2, what does it sum up to? Navika?
Yeah. Just come again. What did you say? What
In
sums
a
up
single,
to?
what does it sums up to? N by 2 plus n by 2.
N.
Exactly. So n by 4 plus n by 4 plus n by 4.
Like n by 4 into 4 again n. Yeah.
Correct. See, this level it is n. This level also sum is equal to n. This level also sum equal to n. This level also sum equal to n. At every level, if the sum of the series is equal to, I mean, are the same, is equal to n,
Yeah.
then you call it as a series is equal. Do you
Okay.
understand?
Yes.
Okay. So then T of n is n log n. Look at this. You got the point here? That's why you're calling it as n log n. So this is exactly the same as we did, right? 6 times if
Right.
you're splitting it. And they sum up to be n. N by 6 plus n by 6, 6 times. Correct?
Yes. Yeah.
Okay. So we have this. Okay, wait. This is unequal partition wherein quick sort with pivot always in the middle third of the values. Okay, see, n by 3, 2n by 3. So n by 9, 2n by 9. So it will take I mean, the right hand side, you will have a much deeper node, I think.
No, here also
Right.
it sums up to n. That is why.
Again, but the sums up to exactly, Uma. So since it's summing up to n,
Yeah.
so the complexity is
What-
still n log n.
Yeah, but the problem is I am unable to find out whether the series is decreasing or increasing. What does that mean? Exponentially increasing. That's what it written.
I'll tell you. I'll tell you that.
From
So one more thing, Uma. So if you have a case like this, see, then look at the depth. Depth is 3n by, I mean, 3 by 2n.
yeah,
Log 3 by 2n. So no, the complexity here is n log 3 by 2n.
yeah,
Just come again on that.
Okay. See, here the left hand side will end up much earlier than the right hand side.
Yeah.
Right? So let's say that you have a 9 over here. That means on the left hand side you will have 3, and the right hand side you will have 6.
6. Yes.
Correct? Again, you will have on the left hand side you will have 2, on the right hand side you will have 4.
Right.
Correct?
Okay. Yeah.
Which you
Understood.
split again. So which means the rightmost edge will be longer.
Yeah. It's taking more time. Right.
Correct. So in order to find a complexity for such a complex thing, so it's simple. So how much do we divide this into? Like, so it will be 2 by 3. I mean the right hand side you are taking 2 by 3, and the left hand side is you are taking 1 by 3.
1.
You do that because reciprocal for that at this point.
Okay.
Yeah, I'll just give you another example so
no,
that
that will
you
be
know.
Srini told, right? The base is the see part. The bottom part will comes as a base. So 2n by 3, how can we write as n by 3 by 2, right? Usually we write the denominator as the base, log base. Like the other problem, n by 6, right? So you will get as 6 log to the base 6n. The same way here, the
Please, once again, can you repeat what you told?
another day Srini told, see, whatever we write in the base, that is the denominator. In the right hand side, what is the
Whatever,
denominator? It's n by 3 by
whatever
2.
we write in the base.
Base.
Okay.
That is
So
a
here, what is the
denominator.
base?
3 by 2.
Okay, you are talking about this. Okay,
Yeah.
3 by 2. Fine.
No, I explained on how the 3 by 2 came.
Okay, you're saying, okay, now we have 2 by 3, 2n by 3
We can write
on this
2n
right
by
hand side.
3 as n by 3 by 2, no? So that becomes the denominator, right?
N by 3 by 2.
Yeah.
You're talking like that?
Yeah, n by 3 by 2.
Okay.
And then 3 by 2 is the
Okay.
denominator, which according to Uma, that becomes the base.
Probably. Okay.
Yeah.
That's the point. Okay. Great. That's okay. We are discussing much easier. Fine. Okay. Right, Uma. So your doubt is when to tell it is increasing or decreasing. Correct, Uma? Is that your doubt?
Yeah, yeah. Hello.
Hmm. Yeah. Yeah. So still this is increasing. Okay. Wait. Here. So this is increasing or decreasing? Look at this.
No, they have not given Gokul. It is exponential.
What? I'm asking you, looking at the picture, you tell me, is it increasing or decreasing?
The series is growing.
It's growing, that's what. So which means it's an increasing series. If it is an increasing series, okay, what formula you have to use? This formula you have to use.
So that means the series, that term is exponentially increasing, right?
Correct.
Okay.
Okay.
What
Navika,
is
Yeah.
look at this. Okay. So here, first time it is n. Okay. So n by 2 plus n by 2 plus n by 2 plus n by 2, which is 2n. Correct.
Okay. Okay. Yeah.
So here, if you see n plus, so this will become as 4n. Next, it will become 8n. So
Right.
this is increasing, right?
Yes.
And the increase is also, exponential, 2 power times,
Hmm. Okay.
correct? So first 2 power 0 power n, I mean, then 2 power 1n, 2 power 2n, 2 power 3n. So, this is going exponentially,
Yeah.
right? So if it is increasing, okay, so this is the formula. Oh my goodness. I think,
You lucky.
yeah, the formula I missed that while taking it. Look at the formula.
N to the power log base C, right?
Log base C and R.
No.
You're correct. Log to the base C and R. So how do we do this? So what is C and what is R?
I think R is 4
Hmm?
in the first case. I mean, like the divisions that we are doing, and I think R is 4. Oh,
Okay.
sure. Yeah.
You're correct. R is 4. Okay. And each split. See, look at this.
Hmm.
How much you are in each particular box. How much are you dividing the total number into?
Hmm.
Hmm?
2.
So in this case, you are dividing it by 2. So which means C is 2, R is 4. Correct. Okay.
Yes.
So we go off n log power. What is C? 2 power 2 power 2. Correct. Log base to 2.
Yeah.
Okay.
Yes. Yes.
Now you can say that now this will become as 1.
1.
That you guys know that, I think so.
Huh.
Hence this is n square.
Okay.
Hence the complexity will become n square. Look at this.
Yes. Okay. Understood.
Uma, you are okay with this now?
Yeah, Gokul. But when it comes to pen paper, we are again back to stuck. Yeah.
No, you don't. You like we will practice it a lot.
Whenever we take this recurrence, you remember we are getting stuck again. Even this formula is not working. So we are stuck.
Why it is not working?
Exam, it is so tough. They are confused us actually.
See, I am just confused with the decreasing part. How do we tell
Yeah,
it?
how can we possibly get a decreasing one? Even I'm thinking. It is
Hey,
only
in
giving.
binary search tree, Uma,
Okay.
what do you do in a binary search? Not tree, but binary search. What do you do? You have a list of how much? Let's say 10,000.
Okay.
Okay. You split into two,
Yeah.
500, 500.
5,000.
Okay.
5,000.
Yeah,
Oh,
sorry, 5,000. Correct. Okay. So what do? You're looking for the, let's say this is a sorted list. Okay, you can do the binary search for a sorted only, right?
yeah, yeah.
Okay, sorted. And the question I'm asking is find
Yeah,
9,600 and 99,696, something like that. So you eliminate the first 5,000 numbers.
yeah.
Now it's gone. So now this 5,000 and 5,000, this is 2,500, 2,500.
Okay, okay, okay. Got
Okay.
it.
Now this 2,500 is also gone. Now this sum up to what? How much? Only 2,500 is left.
Yeah, so this is only
So this
log
is
one, right?
how, yeah, this is how the increasing part comes into picture. Got the point?
Yeah, yeah.
Sorry, no, the
Decreasing.
decreasing part. I'm
Yeah,
talking about decreasing.
yeah, yeah. Got it. Yeah.
And what's the complexity for this? For this?
This is known Gokul binary search, but in the
Yeah.
recurrent relation, it's complicated. It will be given as n by 3, 9 into then n square. In that case, it is really hard. We can't,
Okay.
that is what I want to know, the tree structure of that. Okay, I will try with the n term paper. You can try to.
Yeah, yeah. So I'm just, thinking about, okay, correct. They have given for correct Sura also. Navika?
Yeah.
Navika? So
Hmm.
one more, just like how we saw that, for 2, right? How it is going. So you have one more thing. Look at this. This is an increasing series wherein it increases to 3 by 2.
Yeah.
They haven't given the answer, no, Gokul. Have they given?
They are given.
Can
Look at the bottom.
No. It is only n for log 2, 3? No, right? That's it?
Yes.
Okay, it is not
Oh,
simplified.
oh, you're talking about, plus something will come, right?
No, 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 no. Finally, this is this the answer I'm asking. See, there we have
Huh.
reduced n square, but
Okay.
here we are not able to reduce it, right?
3n by 2. So the sum is coming as 3n by 2. And this is what? R equal to 3
R is 3.
and C equal to 2. Correct? N log, what was the formula?
Gokul,
What
where
we
are you
see
finding
as
that C is equal to 2 now? Here in this picture, where is the C is
C
equal
equal to
to 2?
from this.
it's n
That
by
n
c.
by 2, you are trying by C. Okay, it is not how many blocks it is getting divided into. That is not the C.
That is R.
That is R. Number of blocks is R.
Number of blocks is R. Okay. 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 Right.
Okay. So now come here. So we have C is 2 and R is 3. N power
N
log. Okay.
2 and 3.
That's what that's what this is.
Okay.
See, for this.
Yes.
Okay. See, only thing I'm trying to understand here is for the binary
Decrease.
search tree.
No,
Okay.
binary search is one example, but they are not going to give the algorithm name. They are going to give the
No, no.
relation n by 3,
Yeah,
9. Then,
I want to find a complexity for this. How do I do that? This is a decreasing. Only one side you have, only decreasing you have.
yeah,
How do I find this now?
it is just the height, no? Log 2, log n.
Correct.
You're just splitting into 2, 2, 2. So it is log n, whatever the height of the tree, that's it.
Okay. Yeah, that's the correct answer. Okay, fine. Okay.
Yeah, that's what.
This is so easy.
Yeah, but what about when it is decreasing? In the relations, it is hard to find whether it is decreasing or
Okay. When you
exponential.
get such a question, you tell me. Okay.
Yeah, yeah.
Can we try the
I
next questions? Maybe we find something similar to what Uma is saying.
Yeah, yeah, yeah.
Yeah.
So now that we have understood all these things, you will be able to answer these easily.
in quiz 2, we tried, no, Gokul, I don't know, but we also revised quiz 2. We exactly missed the
Mhm.
recurrence relation part.
Can we do this
Last,
one once quickly?
Yeah,
If
yeah.
we divide the problem into four subgroups.
Go ahead, Navika. You only do this.
Yeah, if we divide the problem into four subproblems of size n by 2, okay, and number of steps S required to combine the solution is 15. Using some optimizations, what will be the nearest upper bound of this algorithm? So R is 4, your C is 2, it's not recursive, is it? It doesn't say
What?
that.
What do you mean?
So in the previous question when we did, it was mentioned that it's recursively the sub problems are breaking down until we reach a point, right? We applied this strategy recursively,
Yeah.
but in this question that's not mentioned.
For question 2 and 3. See this wordings, whatever this wording, I think it's for.
That is understood, I think, Navika.
It should be
Okay.
understood.
Okay.
Yeah, recursively.
Okay. It's going to
Go
be
ahead.
n log base 2. So it's going to be basically, we just did something of that sort now. It's coming to be n square, but that's not
Yeah,
possible.
that's the answer.
Oh, okay, okay. No, I thought the answer is logging. Yeah, yeah. Okay, perfect. Okay.
Equal to this will become as 1 and n squared. Subramaniam, okay with that?
Yeah,
Great.
the same like previous problem, no?
Yes, yes, yes. We have seen that. Now comes a different question. Okay. So what is this question? Please take this. Which of the following options describe the recurrence relation that will give the above recurrence tree? If the cost of the combination at each level is equal to 2n, the cost to compute the subproblems at leaf node is big of 1. Right? Okay.
The first one,
Fine.
because it is n by 3 plus 2n by 3, right?
Correct. So hence we have n by 3.
That is
2
n by
n by
3, right? The left small element is.
Yeah, Uma. This is n by 3. This is 2n by 3. Okay.
Yeah. So the plus the combining value, right? Plus 2n.
And similarly, the fourth one also is.
Fourth one is fine, right? It's big O of n. 2n is nothing but big O of n.
Yeah.
That's understood.
Okay. So this is what this 2n means is that if the cost to combine solution at each level. So at this level, the cost to compute is 2n. So I mean the total thing, right, Uma?
Yeah.
But it is not 2n, no?
That
They are
means
given it.
not at each level, it is not same.
No, but the level.
If you add it, and I think
It says, it says each level.
no, the next level it will be 2n plus 2n, it will be 4n total, right?
8n
n
by
by 3
3,
plus
that
2n
is.
by 3 it is 2n. Then n by 3 plus 2n by 3 it is like we have to again calculate only. It will increase both. That's a
7
calculator
by
is n
3,
only. It won't go to
2, 2 plus n. That's above 2n. I think it's rounded up to
Even
2n
their
in each level.
even their picture is so bad. Look at this. How had this. Okay. So Uma,
value
see this.
Every level it is
increase
only n.
total. The first level is 2n,
Second level also n.
2n, but the second level, okay,
n.
then fine, I have it added. Okay.
The second level is not 2n, no, it's n. n by 3 plus 2n by 3.
The thing is, combining the solution is 2n. Okay. So the thing is, see, you guys understand this something. So at the last level, you have two things. Okay. You'll have one. You'll have one.
Uh,
Do you remember? Do you remember how the merge sort works or quick sort works? What do you do? At the last level, you will have one. Correct. One element. These two you will compare, and you will put it as a
Yeah.
while combining, you'll put 1 comma n, 1 comma 2. Correct?
Yeah, the
But this
time
combining
taken is
operation, it takes 2n times. This combining operation,
Yeah.
it takes 2n times. That n, first n refers to this one, second n refers to this one. The combining takes 2n. Okay. Similarly, on the left hand side, you will have two things which you will be combining. Right? If you want to combine this and this two element and this two element, the total combination. You understand? At every level, the n, it keeps on changing or something like that. Hey, but you don't need to worry. Just put the 2n, whatever they're giving,
Yeah.
nothing else. No sweat. Okay, it's not n, and this is wrong. Shall we move ahead, guys?
Yeah.
Yes.
I believe this is the last question. Yep.
Yeah, I think it's the last one.
Okay. Go ahead. Navika, you want to take this?
Yeah, not sure how to solve it, but I'll try. If
Above
order of
recurrence relation. Okay, they are talking about the same recurrence relation.
okay.
So, what is going to be the complexity?
Time complexity.
Hi, easy. See,
Yeah,
this is
so it's,
equal.
yeah.
Go ahead.
So if it is equal, then it's going to be n log n.
Very good.
It's
Bas, over. This is wrong.
Second
So,
one.
and what is going to be the base one? Can you tell me? We have seen this. We have seen this.
The base for this, it's going to be how much? 2?
two.
No, 3. C is going to be 3 for this.
N log 3 by 2n. Correct?
Why are we taking 3 by 2 as in the first one? Like, if you just look at the second row, right? No, I understood that. I understood that one. But if you just
Mhm.
come back to this question, so n
Yeah.
is basically, it's getting divided into two parts, right? One is n by 3, and the second one is 2n by 3.
Yeah. And
We are looking at the second one. Okay, the one, okay, got it. The one
do a
which is
reciprocal for that.
yeah, understood.
No, I
Okay.
couldn't hear it. Why are we taking the n by 3 by 2 alone?
Because that's the
Navika,
longer,
please.
right? Right,
Whichever
Gokul?
whichever is taking the longer, take that. Correct. So let's say
Yes.
if I give n by 4, okay, and here it is 5n, not 5n. Okay, let me give it as 3n by 4. Uma.
Yeah.
So this, the recurrence goes. Okay. So what you need to put inside of the, base for the log is nothing but the one on which you have the longer length.
Okay.
The right hand side only you will have the longest length, right? So what will be the height of that tree? It will be 2n by 3.
Yeah.
Correct. So the base you're going to put it like 3 by 2n. Got the point?
Yeah. So the longest
The
list we
reciprocal.
are calculating, we are ignoring the smallest one. That's right.
Yes. That question is exactly similar to this part.
Yeah. Yeah.
Hmm. Okay, if it is equal, it's simply n log n. You can simply write it n log n.
Yes.
Yeah.
Right? If it is increasing, just need to calculate it like this. If it is decreasing, make sure you don't
Like
ask
in this
me.
particular question, the one
Yeah.
that's there on your screen,
Hmm?
it's what? It is not equal, no? It's the first one is
Which
n, the
one?
second one is 3n by 2.
The right hand side?
Yeah, this picture.
Okay. First one is n, second one is 3n by 2. You're right. Correct.
This
So
is not equal, no?
this is increasing series, right?
Yes.
So which means it will be exponential. So the value
Right.
goes, look at that. That's what
Yes,
correct
and in raised to
living charges.
yeah, understood.
Hmm. So look at this other recurrence relation. N by 3, 2n by 3. This is equal. So this is nothing but this. N by 3, 2n by 3.
Hmm.
Okay.
Right.
So on the depth test, look at this log base 3 by 2n.
Yeah.
Simple. Okay.
All right. Yes.
Finally.
Thank you
Okay.
so
So
much.
yeah. So we call
This
it a
was
day.
like I was really getting confused. Thanks a lot.
Yep. Sure. No problems.